This is Mrs. O'Neill for Chapter 11, Section 1, Part 6, Writing Chemical Reactions. You should have your periodic chart of ions reference sheet because we're going to have to write the substances out before you can balance the equation. In other words, we need the formulas of the substances. So words to formulas, symbols, then balance. And so I want to remind you of those 7 special diatomic molecules. So when the word says chlorine, you know that you need Cl2, not just Cl. So there is going to be a big difference when we're dealing with those 7 diatomic molecules. So make sure to pause the video and get out that ion sheet and maybe chapter 9 notes. I don't know, maybe to help you out with how to write maybe that flow chart or the review sheet or the review practice problems, just to remind you of how to write those chemical formulas for the names that are given to you. All right, so hopefully you're all prepared here. So what's going to happen is you're going to need to write the formulas of the reactants, and those are going to be to the left of the arrow. And if there's more than one reactant, you're going to separate them by a plus sign. So it should look like a chemical equation. On the right side, you're going to, again, write the formulas of those products on the right side. Remember, products are something that we're producing. They're on the right side of the reaction. And again, if there's more than one, you're going to separate it by a plus sign. So again, you have your reactants, 2 products, R to P. All right, so here are some examples that we're going to go through step by step. So first, we're going to take this sentence, and I have a nice little picture representation as well. We're going to take this sentence and we're going to make it a word equation. That's going to be a lot easier than to look at that word equation and then put it into formulas. So it says when methane gas burns, it combines with oxygen to form carbon dioxide and water. And hopefully it kind of makes sense to you. I kind of highlighted with different colors as to what we're going to use and when. So methane is something that you probably don't know. So I will give you methane. Well, that's for the formulas, but we're going to do, the word equation first. So methane combines with oxygen. So methane plus oxygen, and it says to form. Well, to form, we're going to use the arrow symbol, right? The yield symbol to specify that, to form those words. And what are we forming? We are forming carbon dioxide and water. So you might want to pause, and in your notes, there's a line that tells you that you need to write out this word equation from the sentence. All right, so now going back to methane, methane is probably something you don't know, but if I told you methane was carbon tetrahydride, let me repeat, carbon tetrahydride, can you pause the video and come up with a formula? Hopefully you came up with the formula of CH4. Okay, so now we're going to do the formulas. Again, wait until we do all of them, and then you can pause and write them in your packet. All right, so carbon tetrahydride, carbon tetrahydride is the common name is methane. So we're going to add oxygen. What is the formula for oxygen? Well, hopefully, ding, 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 something goes off into your head because oxygen is one of those diatomic molecules, so it's O2. Then we're going to yield carbon dioxide. I'm going to assume most of you know that by now, very common. And of course, you all know water. So right now, pause the video and you should have the word equation in your notes as well as the formula equation. I will suggest, sorry I didn't do this sooner, but make sure to keep space in front of all of your substances just in case you need coefficients, because that's right, now we're going to have to balance. All right, so if you need scrap paper, because I know I didn't give you room in your notes to do this, if you need scrap paper or you can use the margins, make your list, pause the video, and see if you can come up with how many on each side to begin with. All right, so hopefully you came up with your list. And remember, we want to keep hydrogen and oxygen last. And in this case, it's already last, so that's helpful. All right, so we have one carbon on the left and one carbon on the right. We have 4 hydrogens on the left and 2 hydrogens on the right. We have 2 oxygens on the left, and now we have 3. We want to remember 2 plus the 1 on this side gives us 3 oxygens. All right, so starting at the top, carbon is nice and balanced. However, hydrogen is not. He's our next victim. So what's going to happen is we're going to put a 2 in front of the water. And now we're going to, again, use that like distributive property, right? We want to make sure that the 2, because it's a coefficient, goes with the hydrogen and the oxygen. So the 2 now changes that hydrogen to 4 of them, and it's also going to change the oxygen. But now remember, we got the 2 here from carbon dioxide. So we have 2 plus our 2 to give us 4 oxygens on the right. All right, carbons are still good. We didn't mess around with that. Hydrogens are now good, and now these oxygens. And notice how nice this is. Oxygen is last. We're going to put a 2 there. The 2 changes to a 4, and now our equation is balanced. Now we have a nice balanced chemical reaction, or a nice balanced chemical equation. So pause and make sure to write in those coefficients. All right, on to our next sentence, and now we're going to make it into a word equation first, and then we're going to come up with our formulas. So iron turns to red-brown rust, in other words, iron 3 oxide, in the presence of oxygen in the air. So this one's a little tricky. So iron, okay, turns into, so that's going to be our yield sign there, turns into this iron 3 oxide. But it says in the presence of oxygen. So really in the presence of oxygen is also going to be a reactant. So this is our word equation. Iron plus oxygen gives us iron 3 oxide. So now I'm going to strongly suggest pausing the video, filling in your word equation, and try to come up with the formulas for these substances. All right, so iron, that one's pretty easy. Most of you remember Fifi and Ferris, right? So iron pigs, iron is Fe. Remember your bigs and your littles. Oxygen, like we saw last equation, that it's O2, those diatomic molecules. And iron 3 oxide is an ionic compound. So iron, in this case, has a +3 charge, and oxide is -2. So we want to crisscross those charges. So again, pause the video and make sure to get those formulas in there. I also want to remind you that this is an element, this is an element, and this is a compound. And again, that's going to be really important when we talk about types of reactions. So now we're going to balance. Again, pause the video and see if you can balance on your own now that you're used to balancing from the previous sections, the previous parts of this section, I should say, and then play to hear my words. All right, so here's our list. Whether you need to make them now or not, that again is up to you. You can either do it in the margins of your notes packet or on a scrap sheet of paper. I no longer need to know that, see that information. Remember, I said that sometimes you can do it pretty quickly spot checking, but if there is a reaction that has so many elements and you want to keep better track, you might want to do yourself a favor and make that list. All right, so the original numbers would be a 1 and a 2, a 2 and a 3. All right, let's start with that iron. So we're going to start at the top of the list, and we're going to put a 2 coefficient, and that's going to change our iron. Woohoo! But this is one of those weird ones, right? There's nothing times 2 to give me the 3, and there's nothing times 3 to give me the 2. So we're going to do that lowest multiple, right? That lowest common multiple. And usually the easiest thing to do is multiply them together, right? So 2 times 3 is 6. So we're going to put 6 on each side. And it really doesn't matter which way you do it. I think I did this side first. So 3 times the 2 gives us the 6 oxygens as the reactant side. And now I'm going to put a 2 in front of the iron 3 oxide in order to get the 6 oxygens. But remember, I always like to do things in order. So the 2 times the 2 to give me the 4 irons, and then the 2 times the 3 to give us the 6 oxygens. But oh no, again, this is one of those weird ones. Going back to the top of my list, I have to change my 2 to a 4 in order to get 4 irons on the left. So again, that was one of those tricky ones where not only you have to think about the lowest common multiple, you also had to change a coefficient, and that happens. All right, so pause and make sure to write in those coefficients so you have a nice balanced chemical equation. All right, I believe this is the last one. This one says hydrogen peroxide decomposes or forms or yields. Again, I'm giving you those 3 choices of words because you're going to see them in different ways. So it says it decomposes into water and or plus oxygen. So let's make this into a word equation. Hydrogen peroxide decomposes, that's going to be our yield sign, our arrow. Water, which you all know, plus oxygen. So again, pause the video and then come up with the formulas. All right, so hydrogen peroxide, again, is a common name for dihydrogen dioxide. And most of you kind of know hydrogen peroxide because we've used it and said it in class a few times. And you might even have that brown bottle at home that contains hydrogen peroxide for your cuts and bruises. So we're going to change water into H2O. And of course, oxygen is one of those diatomic molecules. All right, guys, so make sure to pause and get those formulas in. And now, yep, let's balance. So make your list. Again, the list is hydrogen and oxygen. See if you can do it without the list first. But again, I will show you all of that information to make sure you're on the right track. So you should have paused and H and O. So we have 2 and 2. We got 2 and 3. Remember that we have 1 from the water and 2 from the oxygen. All right, so my hydrogens are balanced. Ooh, this is another one of those tricky ones. Do I really want to make 6 on each side? Because my oxygens here are separated, can I somehow get oxygen to be an even number so that if I put a number here, I also have an even number? So my strong suggestion here is actually to put a 2 in front of the water. I'm going to change my hydrogens to 4, and now my oxygens also change to 4. 2 from my water plus 2 from my oxygen is going to give me 4 total. And now look at this. Again, now I got to go rebalance my hydrogen. So I'm going to put a 2 there. That's going to change my H's to 4. And look at that, my O's to 4. So again, this one was a little trickier because I'm not dealing with really the lowest multiple. Between the 2 and the 3. So again, so some can get a little tricky, and that's okay. You need a couple challenging ones to put in there just to make sure that your brain is working. All right, guys, pause and make sure to get those coefficients in your notes. All right, guys, see you in class.